Hi, question number 2. The total mass of a cyclist in his cycle is 80 kilograms. The resistance to motion is 0. The cyclist moves along a horizontal straight road working at a constant rate of pw. Find the value of p given that the cyclist's speed is 5 meters per second when his acceleration is 1.2 meters per second. Now, suppose this is a horizontal surface. The cyclist is here and is moving. There is a contact force, and the force acting downward is 80 G-Newton. The cyclist is moving in this direction. Now we should know that force is equal to the power over the velocity. Right. Now we know that the velocity has been given in the question as 5 meters per second, and the acceleration is 1.2 meters per second. Therefore, also we know that the force is equal to mass times acceleration. Hence, we have the force is equal to 80 multiplied by 1.2, and what is this force again? It is power over velocity. Therefore, 80 times 1.2 is equal to the power over the velocity, which is 5. In other words, we're saying P is equal to 5 multiplied by 80 multiplied by 1.2. And if you were to work this out in your calculator, you'll end up with 480 watts. So here we are for the first part of the question. Now, for the second part of the question, the cyclist moves up a straight hill inclined at an angle of theta, where the sine of theta is equal to 0.035. Find the acceleration of the cyclist at an instant when he's working at a rate of 450 watts and has a speed of 3.6 meters per second. Okay, let's just move on to the second part of the question. The situation has changed. Now the cyclist is moving uphill. So this is alpha. I was saying theta earlier on. The cyclist is here. Alright, so this is the contact force, and the force acting downward will be 80 G-Newton. Here we have the angle as alpha again. Remember, the cyclist is moving upward, so there's a resistance to motion acting downward. What is the downward force? Let's call it FD. It's going to be 80 G multiplied by the sine of alpha, and therefore we have 80 multiplied by 10 multiplied by the sine of alpha. The sine of alpha has been given in the question as 0.035, and therefore if you were to work all of that, you're going to end up with 28 newtons. What is the driving force of the cyclist? Now we should know that force is also power over velocity. The power, we are told in the question, is 450 over the velocity, which is 3.6. Alright, so, and if you divide that, 450 divided by 3.6, 125 newtons. So we have the force as 125 newtons. Now, what is the net force? The net force is going to be the force acting downward minus the force acting upward. So the net force is going to be 125 minus 28, which is 97 Newton. Also, what we know from Newton's second law of motion, that force is equal to mass times acceleration. The net force we calculated was 97, is equal to the mass of the cyclist, which is 80, times the acceleration. Therefore the acceleration is going to be 97 over 80, and if you take 97 divided by 80, 1.2125, so that's going to be 1.2125. Therefore your answer for the acceleration is going to be 1.21 meters per second to 3 significant figures. This question is taken from October 2016, A-Level Maths HSC Mechanics 1.